So this is rationalizing substitution. So what we're going to do is use substitution to get rid of our radical. And so how we do that is this. We take u equals the square root of x minus 1. And then now if we square both sides, we end up with this. So now when we take the derivative, we get 2u du equals dx. And now if we plug this in, everything should be nice. So we plug in our u, which is there, and we plug in our dx, and so we end up with 2u, and put the du out here, and then u down here for the square root of x. But we also need to take care of the x. Well, all our substitution formulas are here. So there's x. So if we rewrite this, we get x equals u squared plus 1. So now we have something to plug in here. And you can see that we have a u here and a u here, and so they cancel. And we're ending up with the integral of 2 over u squared plus 1 du. And that's a nice quick one because that's just the inverse tangent. So this is 2, we got to take it out, 1 over u squared plus 1 du, which is 2 inverse tangent of u plus c. And then now all we have to do is go back up and grab our u. So 2 inverse tangent square root x minus 1 plus c. And so that is rationalizing substitution. So you can see what we did is we rationalized it. We had a radical, and now we don't. All right, let's try it again. All right, so if you look at this one, there's our radical. So that's where we're going to start. We're going to start with our u equals the square root of x, which means u squared would equal x. And so 2u du is dx. So let's see, we've got the dx. Let's just do a little highlighting here. So there is our u, which is the square root of x. We'll pick yellow for the dx. That goes here. All right, so that's taken care of. So now what we need to do is take care of the x. And the x squared we can do together. So if you see x is equal to u squared, so that's taken care of right here. So then if you think about it, that would mean that u to the fourth is also equal to x squared. So if we square it again, we get the next one. All right, so everything's plugged in except for our numbers here. So that means x is equal to 1, because this is with respect to x here. And we also have x is equal to 4. And we need to plug those in. So right here is the u that we need. Everything now needs to be in terms of u. That's what we're trying to do, is an x to u conversion. So we need to do a little substitution here. So our u is this one. So u equals the square root of 1, which is 1. And u equals the square root of 4, which is 2. So we are now going from 1 to 2, and we can substitute everything in. So 2u du. Our x squared is u to the fourth. Our x is u squared. And then our radical x is the u. So just so we can see it, that goes here, here. There's a lot of substituting going on here. And right there. So that's everything converted. And so now we just need to integrate this. So that cancels with that, right? No, it doesn't. See, what we have here is a common u. And so what we want to do is always make sure that the bottom is factored. So this is the integral, oops, still in red, of 1 to 2 of 2u, and I'm going to put the du outside now, of u to the fourth plus u cubed. We can take our time. And so what we have to do is make sure it's all multiplied before we factor and cancel. That's the key. It has to be factor kill. So on the bottom, what we want to do is get rid of a u, right? So we're going to take out u cubed. And then u plus 1 is what we get. So we're going to factor it first. And then now I can cancel the u. It needs to be fully factored first. So we integral from 1 to 2 of 2 over u squared u plus 1 du. Now look familiar? That's why this is in this section. These are our partial fractions. So we have u squared, which means we're going to need, I'm going to go up to the top now because I've got room up there. This would be a over u plus b over u squared. So he's taken care of, plus c over u plus 1. And then that's all of them. So if we multiply this, the a is going to need a u and a u plus 1. The b is already got the u squared, so it just needs a u plus 1. And the c needs the full u squared. And then that way we will end up with u squared u plus 1. So you should always see it. This is u squared u plus 1, u squared u plus 1, and then u squared u plus 1. So they all give us the same common denominator. Okay. So now we're going to have a, b, c. And our first one is u squared plus u, and I'm leaving a space here. So I know it's u squared, so I've got 3 terms. And then the next is u plus 1. And the last one is just u squared. All right, and then these all have to add up to 2. Okay, so remember this is 1 and 1, and that makes 0. This is 1 and 1 and 0. So that means a plus c is equal to 0. And a plus b is equal to 0. And the last one is just b is equal to 2. So this looks like a nice quick substitution here. So b is 2. So let's go to the next one. A plus b equals 0. So that's a plus 2 equals 0. So a equals negative 2. And then the last one would be a plus c equals 0. So negative 2 plus c equals 0. So c equals 2. All right. So that means a here is negative 2, b is 2, and c is 2. So we end up with the integral from 1 to 2 of negative 2 over u plus 2 over u squared plus 2 over u plus 1 du. And so this would become negative 2 natural log of u. And then it's minus 2 over u, because remember that would be u to the negative 2, right? So then we would add 1, making it negative 1. So then it would just become negative 1 here with a negative in front. Plus 2 natural log u plus 1 from 2 to 1. All right, so let's do the 2 first. So this is negative 2 natural log of 2 minus 2 over 2 plus 2 ln 2 plus 1 is 3. Okay. And then the next one would be 1. So negative 2, positive 2, we're subtracting ln of 1 plus 2 over 1 minus 2 ln of 1 plus 1, which is 2. All right, well, this is 0. It's gone. And then that's negative 1. So we end up with negative 2 ln of 2 and negative 2 ln of 2. So that would become negative 4 ln of 4. We don't need the negative anymore. And then we also have a 2 ln of 3. The absolute value, we don't need that anymore, or here. And then this would be a negative 1 plus 2, which is 1. And then we could even combine this again and say you could bring the negative 4 up here and the 2 up here and then bring them together. But I'm going to leave them alone in this expanded form. And if we check it in the calculator, you'll see it's wrong. That's right. I always do these little simple errors because I'm saying 4, and so I write 4. But that's supposed to be a 2 because it's negative 2 ln of 2 and negative 2 ln of 2. So ln of 2 is our like term. We get ln of 2. And that one checks. So let's go back and fix that. Erase this out of the way. Put the 2 back in, and now we are good. So that is your rationalizing substitution. So sometimes you will just do rationalizing and you're done. And then sometimes you're going to end up with a fraction that you're going to have to use partial fractions with, break it apart, and you're good to go.